Hello guys! Back at it again with another tutorial. So for today's video, together with my team, we will be teaching you on how to write and name chemical formulas. Without further ado, let's get started! Let us start with the first classification, the binary compounds. Just like bicycle and bilingual, bi means two. So binary compounds is composed of strictly and precisely two distinct elements. It may be one from each element, just like sodium chloride, or more than one of each element, like dihydrogen oxide. It comprises of three types, with the first being type 1, binary ionic, composed of group 1 or group 2 metal with a non-metal. Type 2, binary ionic, but it is composed of transition metal and a non-metal. Enter the type 3, which is a binary molecular compound composed of two non-metals. Where could we find them, you might ask? Don't worry, because I will help you. These are the group 1 and 2 metals, the transition metals, and the non-metals. So if a green is mixed with an orange, it is under type 1, while a blue mixed with an orange is under type 2, and an orange mixed with another orange is under type 3. It is also important to remember the charges of elements, starting off with positive 1 on group 1, positive 2 on group 2, positive 3 on group 3. On the other side, we could find the negative charges. Starting off with negative 1 on group 17, negative 2 on group 16, and negative 3 on group 15. You can take a screenshot now to help you remember this. Let us move on with the next type, which are the ternary compounds. This comprises of more than two distinct elements, just like fluorine nitrate. Since there are three colors, we would know that three distinct elements are present in this compound. It could also be further divided into ternary ionic and ternary molecular, depending on the element bonded with the polyatomic ion. Next, if the element bonded with the polyatomic ion is specifically hydrogen, this falls under the type of ternary acid, because it comprises of a polyatomic ion bonded with a hydrogen. This is an example, acetic acid.
We will tackle about type 1 binary ionic compound. We should consider these non-metal elements and these metal elements. It's very basic. In this example, we have rubidium oxide. So the chemical symbol for rubidium is Rb, and for oxygen we have O, and the charge of Rb is 1 and the charge of oxygen is negative 2. So in order to get the neutral or to get the charge as 0, we will add another rubidium, and 1 plus 1, 2, then 2 minus 2 is 0, so it's neutral now. Then we have this rubidium 2 oxide, because there is the rubidium here, we have 2 here and then 1 here, so rubidium 2 oxide. Next is the vice versa. We take the name of rubidium and the oxygen. This is a type 1, so no need to indicate the charges. So in here, we will take the root of the second element, which is the non-metal oxygen, disregard it, and placed IDE. So the final name for this is rubidium oxide.
Hey guys, so example, we will now discuss the type 2 binary ionic. So let's get started. So our example will be the manganese 4 oxide. So just like the other example, the first step is to determine its element. So it's Mn with a positive 4 and O with a negative 2. So the next step is to do the crisscross method. So oxygen will now have 4 charges and Mn will now have the 2 charge. So we all know that 2 and 4 are both divisible by 2, so we will divide it. And the answer will be Mn1O2. So this is the easiest way to solve or to determine the symbol or the element of it. But I've provided another great way to solve this. So we, just like the other one, first determine the element or the symbol. So we have Mn 4 plus and O with a negative 2. So we all know that 4 and 2 are not balanced. So we will add another oxygen with a negative 2. So we will now have a positive 4 and a negative 4. So just like on the PowerPoint, you will add the positive 4 and a negative 4, and it will be equals to 0, and that is balanced. So just like the other one, the answer will be Mn1O2. But in this case, we don't usually type or write the number 1. So our final answer will be MnO2. So that's it for our last example. I hope you learn and enjoy.
Let us now move on with the type 3 binary molecular compound. Again, these are formed when two nonmetals are molecularly bonded together. These are colored orange in our periodic table. We name this just like the first type of binary compound. However, we add prefixes according to the number of atoms present in an element. We use mono for 1, di for 2, tri for 3, and so on. Please take a screenshot if you would like to go back to this later. However, please do remember that we do not use mono even if the number of atoms is 1 when an element is used at the first part of the compound. Let's use this as an example. Oxygen dichloride. Even there is no prefix, we would know that the atom in here is 1, since we know that mono is omitted. So for the first step, what are their chemical symbols? O for oxygen and Cl for chlorine. Next, how many? 1. And since di means 2, 2. Next, we omit the number 1 since we do not use it in chemical formulas. OCl2. That is our final answer. What if we do the reverse? OCl2. How would we name and read this? Since we should know what are the elements present, it is oxygen and chloride. Just like the first type, however, we should add the prefixes. Since we do not see any number here, it means 1, but we would not use mono. So it stays as oxygen. Since 2 means di, we use dichloride. We add di to the word chloride. And that is already our final answer.
Here is the example of ternary ionic compound. First, we should determine the transition metals, and nonmetals. And in this example, we will use a transition metal and a polyatomic ion. Here's the list of polyatomic ions. So we have here negative 1 charge, negative 2 charge, negative 3 charge, and positive 1 charge. In this example, the chemical symbol for tin is Sn and the chemical symbol for hydroxide is OH. We should see the Roman numeral of tin to be its charge. So the charge of tin is positive 2 and the charge of hydroxide is negative 1. So we need to add another hydroxide to become neutral. So 2 minus 2 equals 0. Then we have here 1 tin and then 2 hydroxide. So we have SNOH2. So in this case, the last element of the polyatomic is a polyatomic ion, and the rule when there is a subscript to a polyatomic ion, we should indicate the open and close parentheses before the subscript. Next, on the other hand, the also want to learn how it is formulated vice versa. So we will need to identify its chemical name and its charge. And we do again the second step to become it a neutral charge. 2 hydroxide times 1 tin is equals to 2. And remember that tin is a transition metal, so we need to indicate the subscript as it's the Roman numeral. This tin. 2 is the subscript of tin, so it has 2 Roman numeral. And then the name, tin 2 hydroxide. Simple as that.
Hello guys, now we will talk about the ternary acid. So our example will be the boric acid. So let's get started. So the first thing that we need to do is to determine its element. So we will have the H3BO3. The next step is to separate it from each other. So we will have 3H and BO with a negative 3. So the next step is to determine its name. The name will be boric. And we all know that when an element is ending with A, T, and E, it will be replaced by an I, C, and follow the word acid. So the borate will transform into a boric and followed by the word acid. So we will have the boric acid. So that's it for our ternary acids.